This video is on multiple slit diffraction and diffraction gratings. Question 1. Draw an intensity versus displacement graph for Young's double slit experiment. So do play with these two simulations and draw an intensity versus displacement graph for double slit. There's some great simulations online. Question 2. State the equation for double slit constructive interference and define each variable. So remember, this equation is going to give us the locations of constructive interference. Okay. So it tells us to state the equation. So remember this. If big D is much larger than or longer than little d being the distance between the two slits, then that shows that most of the action is in the middle here. And this here is a path difference, because we're assuming that these two blue lines are parallel to each other, because big D is much longer than little d. So remember, for math class, sine of theta is about tangent of theta is about theta. And theta here is a S over D, big D. And remember, for constructive interference, d sine theta is equal to n lambda. So for small theta, sine of theta is about tangent of theta. And tangent of theta here is about 2s over big D. So this highlighted equation is what we learned in an earlier video about double slit constructive interference. Okay. So let's state the equation for double slit destructive interference. So instead of n, we have n plus 1/2. Okay. Question 4. Go to the following websites and carefully draw an intensity versus distance graph for the following number of slits. So for one slit interference, it looks like this. For two slit interference, it looks like this. For three slit, it looks like this. 4, it looks like this. Now we could see something. For 3 slit interference, it looks like between the two primary maxima, there's one, you could say, secondary maxima. No, not so tall. Between the two primary maxima, we have 2 secondary maxima. Now for 5 slits, we have 3 secondary maxima. For 6 slits, we have 4 secondary maxima. So like 6 minus 2 is 4. For 7 slits, 7 minus 2 is 5. So we have 5 secondary maxima. For 8 slits, we have 8 minus 2, which is 6 secondary maxima. So 9 minus 2 is 7 secondary maxima between the two primary maxima. Finally, if we have 10 slits, in an earlier video we had 1 slit, then in another video we had 2 slits, and now this is 10 slits. For 10 slits, we have 10 minus 2, we have 8 secondary maxima. So let's describe the meaning of a single slit envelope. It's this dotted line here. The intensity versus distance graph for multiple slits is within a single slit pattern. The single slit pattern is like an envelope which contains a multiple slit graph inside it. So this dotted line is a single slit, and inside it we have the multiple slit pattern. What happens to the intensity pattern as the number of slits increases? So we're going to go from 2 slits to 3 to 4 to 5. If the number of slits increase, then locations of constructive and destructive interference will appear at the same locations on the screen as double slit interference, but will be more sharp and narrow. The intensity of the central maximum is proportional to n squared, where n is the number of slits. There will be primary maxima and secondary maxima. The number of secondary maxima, which is between the primary maxima, will be equal to the number of slits minus 2, n minus 2. And as the number of slits increase, the intensity of the primary maxima becomes very sharp. And the intensities of the secondary maxima go to 0. So this is what multiple slit diffraction patterns look like. You could see with 3 slits and 4 slits, we could see the secondary maxima. So this is from this website, geogebra.org. Great website. Question 7. What is a diffraction grating? What is its purpose? A diffraction grating is an object which has a large number of slits which are close together. Its purpose is to show us diffraction patterns. So if we have a white light source come in, then we get Roy G. Biv. You see in the middle we get white, then we get destructive interference, and then we get Roy G. Biv. So if the number of slits increase, then we get this. Question 8. Describe the equation n lambda equals d sine theta for multiple slit diffraction. So n equals 0 is a central maximum or primary maxima. N equals 1 is the location of the secondary primary maxima. N equals 2 is the location of the third primary maxima. You get the point. Question 9. While observing a gas discharge tube through a diffraction grating, which has 600 slits per millimeter, you note that the first bright yellow emission line is visible at an angle of 20.6 degrees from the center antinode. Antinode means constructive interference. Center antinode means the central maximum. What is the wavelength of this yellow light? So we're solving for lambda. The central antinode means n equals 1. Question 10. A diffraction grating which contains 600 slits per millimeter is used to observe a gas discharge tube containing mercury gas, and the first bright violet light is visible at an angle of 15.1 degrees from the central antinode. Part A, what is the wavelength of this light? So make sure your calculator is in degrees. Let's solve for wavelength. Part B, at what angle will the second order antinode appear? So n equals 2 because it's second order. We determine the wavelength from part A, and which this is a mistake. This should be theta. This should not be lambda. It should be theta equals 31.4. Question 11. While looking through a diffraction grating at a nitrogen discharge tube, you note that light with a known wavelength of 5679 angstroms is visible at an angle of 37 degrees from the central antinode. How many slits are there in this diffraction grating for each millimeter of width? So we're going to solve for D here. So we know that n equals 1. We know theta equals 37 degrees. They gave us lambda, so let's solve for D. And they want not slits per meter, they want slits per millimeter. So we have to do a unit conversion. Question 12. You are looking through a diffraction grating which contains 520 slits for each millimeter of width at a light source emitting light with a wavelength of 5890 angstroms. At which angles will the first and second order antinodes be visible? So make sure your calculator is in degrees. So we have n equals 1 and n equals 2. They gave us the wavelength. They gave us lambda. D they also gave us 520 slits per millimeter. Let's just solve for theta.